Okay, this is exam 1 for physics 101 from fall 08. Number 1, which of these is the standard for the kilogram? Currently the standard for a kilogram is the mass of a particular cylinder in France. The volume of a room is 1,000 cubic meters. What is its volume in cubic centimeters? So 1,000 cubic meters. We know that in 1 centimeter there are 10 to the minus 2 meters, or I sort of prefer to do it this way, that in 1 meter there are 100 centimeters. That's a little more intuitive. Now you have to cube this term because this term is cubed, and that gives us 100 times 100 cubed, which is the answer, which is B, 1 times 10 to the 9th. That's in cubic centimeters. In this one you're supposed to consider these equations, which is dimensionally correct. So we just want to look at the units for each. Let's take number 1 first. X is in meters. X is in meters plus x squared, which is meters squared, divided by the velocity, which is meters per second, and time, which is in seconds, plus second time squared, which is second squared, times the square root of acceleration squared, which is meters squared over seconds to the 4th. Now this is meters, here our seconds cancel and one of our meters cancel, so we're left with meters there. Now this one simplifies to second squared times meters per second squared, and those cancel, so number 1 is correct. Well, let's go ahead and look at the other ones. In the second one we have meters for x equals meters plus meters per second squared times time, which is seconds. That gives us meters per second for that one, so I'm just going to skip that one. That one is not correct. For the third one, AMX, A is meters per second squared, M is kilograms, that's mass, and X is in meters. That's equal to kilograms, velocity squared, which is meters per second, and then both terms are squared, plus kilogram, meter per second, meter over seconds. So here we're left with kilogram, meter squared per second squared, which is the same that we have here, so that's correct. Now this one simplifies. If you bring the seconds up, it's like saying 1 over seconds in the numerator, and so that is kilogram meter squared per second squared. So they all have the same units of kilogram meter squared per second squared. So number 3 is correct. So just by elimination we could go ahead and say that the answer is D, 1 and 3, because there is no 1, 3, and 4. But let's go ahead and look at 4. You have velocity squared, which is meters per second squared, and that's equal to meters times meters per second squared. So those are still consistent units. The second one is V0, which is meters per second squared times time, which is seconds. So that cancels there, and we're left with meters squared per second squared, so that's still okay. Plus x, which is meters per second squared. Alright, so we have meters per second squared here, meters squared per second squared here, rather, so that's still consistent. We have meters squared per second squared there, so that's consistent. So far we're all okay. But here we get meters cubed. We have 3 m's in the numerator per second cubed, so that is not correct. So the answer is D. Okay, in this operation of arithmetic, which is the appropriate answer? Let's see, we're multiplying numbers. When you multiply numbers, you keep the lowest number of sig figs. So the lowest number of sig figs here looks to be 2. This one right here only has 2 sig figs. So the number that we want to have should have 2 significant figures, and that's this one, 3,400, D. Alright, with your fingers together, what is the area of your hand from wrist to fingertips? Well, your hand, if you look at it, is approximately 10 by 20 centimeters. Alright, so that's equal to 200 square centimeters. But then all the answers are in cubic meters, so you have to convert that to meters. So there are 100 centimeters in 1 meter. and then you have to square that, so that's 200 over 100 squared, which gives you the right answer, which is 0.02 meters squared. If you look at all the other answers, none of the other answers are reasonable at all. They're like a meter by 2 meters or 1 centimeter by 2 centimeters, so none of the others are viable answers. The mass of an object is related to its acceleration and displacement by this relationship. What are the units of the constant b? Well, let's just look at the units. We have the mass, which is kilograms, and that's equal to some units that we're not sure for b times the acceleration, which is meters per second squared, and then 1 over the displacement, which is meters. So we want this side to be in the units of kilograms, because that's what this side is. Now the meters already cancel, so in order to cancel out the second squared, we're going to need a second squared in the numerator, and then we're also going to need a kilograms in the numerator. So the units for b are kilograms second squared, which is a. Okay, in this figure, the coordinates are given for the point, the coordinates in the Cartesian coordinate system. If you want to express in the polar coordinates, that is what is r and what is theta, how would you do it? So we can find the magnitude of r from the Pythagorean theorem, square root of 3.5 squared plus 2.5 squared, and that gives us 4.3. And then if we want to know theta, I'm going to do the inverse tangent of y over x, that's 2.5 over 3.5. If you put this in your calculator, you get about 36 degrees, but recognize that this is this angle, so you have to add 180 to it, so the actual angle is 216 degrees. So 4.3 at 216, that answer is C. Which of these quantities is scalar quantities? Let's see, that's a scalar quantity, acceleration is a vector quantity, and speed is a scalar quantity. Velocity is a vector quantity, so that's 1 and 3, which is the answer C. Alright, you throw a ball up in the air and it returns to your hand. Right, you throw a ball up in the air, goes up, and comes back down. Alright, which of these graphs represents its motion? Well, initially, you have a positive velocity with a negative acceleration. Alright, so this one right here has a negative acceleration because the slope is negative, but it also has a negative velocity, so that one can't be right. This one likewise has a negative velocity. Alright, this one, C and B both have positive velocities initially, and they both also have negative accelerations. See, the slope of this line is negative and the slope of this line is negative. That means that you have negative accelerations, and the velocity is in the positive region of the coordinate system. Now, at this point, the velocity equals 0, which is true here and here. The velocity is equal to 0. And here, the velocity is negative, and the acceleration is also negative. So, in this one, you have a positive velocity, because the velocity is in the positive region of the coordinate system. So that one's not right. So the answer must be B, which you see you have a negative velocity here and a negative acceleration. In this graph, what is the instantaneous acceleration at point C? Alright, you just want to know the slope at this point. That's rise. The rise is 4 minus 2 over run, which is 4 minus 3. And that's equal to 2 over 1, which is 2. Alright, but my rise here was actually a negative value, but I prefer just to look at the line. So if you look at this line, it has a negative slope. So the answer is actually negative 2, because it has a negative slope. If you wanted to look at it more rigorously mathematically, for the rise, you would say y final minus y initial. So actually your rise would be 2 minus 4, because this is your y final, and this is your y initial, 2 minus 4. In the previous graph, what is the average velocity between points A and C? So that's from here to here. Average velocity I'm sorry, this was supposed to say average acceleration here. That was a mistake. So this should say acceleration. The average acceleration between points A and C, average acceleration is equal to v final minus v initial over delta t. Here v final is 3, v initial is 2, so that's 3 minus 2 over delta t, which is it's like 3.5 minus 1 over 2.5. So 1 over 2.5 is 0.4. The answer is D. 11 is D. A guy throws a ball up into the air. Guy throws a ball into the air at a speed of 20 meters per second. What is the maximum height that the ball reaches? Alright, so we know that its initial velocity is 20 meters per second. We know that the acceleration is minus 9.8. We first need to find out the time. If it goes up and comes back down, we know that the velocity up here is equal to 0. So we say v is equal to v0 plus at. 0 is equal to 20 plus minus 9.8 times t. So t works out to be 2 seconds. Alright, so we want to know what is the height when the time is 2 seconds. The time is at 2 seconds right up here. So if we want to know that height, we just say y equals y0 plus v0 t plus 1/2 at squared. That's equal to 0 plus 20 times 2 plus 1/2 minus 9.8, 2 squared. And that gives us our y displacement, 40 minus minus 19.6, which is 20 meters. So the answer is C for number 12. Alright, when throwing a ball straight up, which of the following is true about the velocity and acceleration at the highest point in its path? We know at the highest point that the velocity equals 0, it comes to a stop, but that the acceleration is always equal to minus 9.8. So the correct answer is D. Which of the following best describes the motion at the point A? Well, at the point A, we have a negative instantaneous velocity. We don't have a continuously increasing position. Actually, at point A, the position is decreasing because the position is going down. We don't have a decreasing velocity because actually the velocity is increasing. We have a negative velocity, so it's not positive, and we don't really know what the acceleration is, so the answer is E. This problem is a little bit confusing, and when I gave it in the first class, I probably wouldn't give you one exactly like this, though you should be able to interpret the slope of a graph. Alright, a car travels initially at 10 meters per second. The driver sees a traffic light up ahead and slows down at a rate of 2 meters per second squared. That means the acceleration is minus 2 meters per second squared because he's slowing down, so it's in the opposite direction of the velocity. It requires 5 seconds. What distance does he cover? X is equal to x0 plus v0 t plus 1/2 at squared is equal to 0 plus 10 times 5 plus 1/2 times minus 2 times 5 squared. And that gives us an answer of let's see, 50 minus 25, which is 25 meters. Which rounds up, just keeping one sig fig, to 30 meters. So number 15 is B. You drop a ball from 12 meters above the floor. How long does it take the ball to hit the ground? Well, let's see. Y is equal to 12 meters. A is equal to minus 9.8 meters per second squared. And V0 is equal to 0. That's really all that we know. Y is equal to Y0 plus V0 t plus 1/2 at squared. V0 fortunately goes to 0. This goes to 0. So we can solve this. Say 12 is equal to 1/2 minus 9.8 times t squared. And if we solve this for t, that's the square root of 12 divided by 4.9. 2.4 seconds. The square root of 2.4, which gives us the answer 1.6. A little bit about signs here. You might have noticed I sort of glossed this over, because if I divide this number by this number, that gives me the square root of a negative number, which is an imaginary number. The y displacement is actually negative 12. If you think about it, you're dropping it from here, that's y equals 0, 12 meters. So this is y equals minus 12. So that's your y final. So your displacement is actually negative 12, and that gets rid of that negative. Which of these statements represent the motion in this plot? We have a decreasing slope. It's big here, small here, and it's always positive. So we have a decreasing positive velocity. This graph represents the position of a particle over a time of 5 seconds. What is the particle's instantaneous velocity at 3.5 seconds? 3.5 seconds, the slope is 0. So the answer is D. Okay, while exploring a cave, a spelunker starts at the entrance and moves the following distances. I'm going to draw it. You have 30 meters to the west, so that's 30 meters in the negative x direction. So 30 meters to the west. 20 meters at an angle 40 degrees north of east. Alright, north of east, this is north and this is east. So it's like this. So this is 40 meters at an angle of 40 degrees. Actually, this is, 20 meters, 20 meters at an angle 40 degrees north of west, and then 100 meters south. So I want to add up my x and the y components of these three vectors. The first one has a negative x component, negative 30, and 0 y component. The next one has an x component of 20 cosine of 40, and a y component of 20 sine of 40. And then the next one has 0 x component and minus 100 is the y component. Now if I add up my x components, that's 20 cosine of 40 minus 30, that's equal to minus 15 meters. And if I add up my y components, that's 20 sine of 40 minus 100, which is equal to minus 87 meters. And then I want to know the magnitude. That's the square root of 15 squared plus 87 squared, and that's equal to 88 meters. I could have just as well asked what is the angle, alright, in which case you'd have to use the inverse tangent. But the answer is 88 meters. That's B. Alright, here we want to know what is the answer for B minus A. Alright, this is the vector B. Negative A is in the opposite direction. So that is the answer, the vector that looks like that, which is D. Okay, an artillery shell is fired with an initial velocity of 300 meters per second. It fires, hits the side of a mountain like this at 31 seconds later. We want to know the height. Y is equal to y naught plus v naught yt plus 1/2 ay t squared. Y is equal, well, y is what we want to know. Y naught is 0. V naught y is 300 sine of 45. T is 31 seconds. Plus 1/2 minus 9.8 times 31 squared. And that gives me the answer, which is number 21 is E, 1900 meters. Okay, number 22. Which of these statements about the motion of a projectile is true? The x component of the velocity does not change. That is true. The y component of the velocity increases throughout the trajectory. Now the y component of the velocity will decrease initially. It'll be 0 at the top, and then it increases in the negative direction. So that's not really true at all. So we'll just cancel that out. The x component of the acceleration is 0. That's really just number 1 restated, and that's true. The maximum height is dependent on the x component of the velocity. That's not really true at all. The maximum height is only dependent upon the y component of the velocity. And the maximum range is dependent on only on the x component of the velocity, what x is equal to v naught xt. So it is true that x is dependent upon v naught x, but it is also dependent upon t, which is a function of your y motion. Alright, so that's not true. So the answer is 1 and 3. Alright, the vector A has components AX and AY. If AX is greater than AY, which of these is a possible angle for A? So AX, the magnitude of AX, is greater than AY. Alright, so we know that this angle has to be less than 45 degrees. Alright, so that's going to get rid of 1. 2 is a possible answer. 3 is a possible answer. And 4 is not, because it has to be less than 45 degrees. So the answer is 2 and 3. Alright, you fire a pistol which gives the bullet an initial velocity of 300 meters per second. A certain angle. The bullet is airborne for 2 seconds. The bullet lands 300 meters from the shooter. What angle is the gun fired? Well, x is equal to v0 xt. So 300, which is the x displacement, 300 meters, is equal to 300 meters per second times the cosine of the angle times 2. And then we solve this. So see, the 300s cancel out. Cosine theta is equal to 1 over 2. So theta is the inverse cosine of 1/2. And let's see, that is 60 degrees. So it's B. A cart is accelerating along a flat surface. A cannon on the cart fires a ball directly overhead. When does the ball land when it comes back down? Number 25, a cart is accelerating along a flat surface. A cannon on the cart fires a ball directly overhead. Where does the ball land when it comes back down? Well, this is straight from the concept test. If it's accelerating, the thing falls behind the cart. You drop a package from a plane flying at a constant speed without air resistance. The package will remain vertically under the plane while falling. The answer there is B. And of course the answer here is A.